All right, guys, going live. All right, welcome back. We are Game 3001. That's Artificial Intelligence for Games in the winter 2022 semester at George Brown, and it's week 12, part 2 of our broadcast and recording. This is the lab recording. All right, so when we got together on Tuesday, we talked about where we're sitting at. We're sitting at, last week we talked about behavior trees, and this week we're doing goal-oriented behavior. We talked about that a little bit. Lab 7, part 2 is quite involved, and that's the part we're working on this one. We're actually going to, instead of building these necessarily, we're going to build these actions. We're putting them in place, but we're actually, what we're doing instead of these things, I'm just going to note it here for future, is we're adding two new enemies, right? We're adding the close combat enemy. That's what we're doing. And we're also adding the ranged combat enemy. In order for us to do that, we need to restructure our code in a couple ways. One, we want to move the tree itself into the close combat enemy and ranged combat enemy code. That's what we want to do, right? And in order for us to do that, we have to restructure. So we're going to remove the build. This is one thing we've done. Remove the build tree function from the decision tree. We're not going to put it there anymore, and we're going to put it inside of the of each of the enemies, right? So each of the close combat enemies, right? And add the build tree function, right, to each enemy. That's what we're going to do. We're also going to be adding a reference to a tree in each enemy, right? So add reference to the tree, decision tree, to each enemy, and that's going to be the enemy's brain. Yes, that's what we're going to do today. So slightly different. We're still going to build out some of these actions. We're not really doing this piece, revisit, seek, and arrival. We're not doing those kind of things right now, but we are doing these pieces today. So it looks like a lot, and Alex has really set up a bunch of little things in his notes that we're going to follow today. All right, let's move on to the next piece, which is actually doing the work. So just like last time, what we're going to do is we're going to start with a lab. So game 3001 in the desktop folder for me. I have section 400. That's you guys. I have lab 7.1. I'm going to make a brand new one. I'm just going to copy paste this one. Copy paste, and it's going to give me lab 7.1 copy. And I want to start with that one and call it lab 7.2. So kind of simple. And this is what I recommend if you want to keep lab 7.1 clean, and so you can always refer back to it if there's an error with 7.2. It's no problem. However, if you want to continue from lab 7.1, the one we did last week, and make the new one, or continue with this one, it's fine. If you called yours lab 7, I'm going to add things to this one. Okay, that's what I'm going to do. So again, I'm going to double click on this one to start. And let's follow Alex's instructions, which are up here. I'm also, by the way, sharing the link to this video that we're doing right now for those people who need it. All right, so way up at the top. So these are the things that are going to change. Lots of little changes that we're going to do today. And here is the setup. We're going to use our completed lab 7.1 to start, which is what we're doing. And we have a couple of new files that I've downloaded. They're actually here in the under labs. Alex has added a couple of new files, some exciting stuff. One is a small D7. The D7 was a Klingon warship, if you're into the Star Trek stuff. Again, it was kind of preceded by the D5, so this is kind of cool. The Klingon music that he's added in there, I think, comes from Star Trek: The Motion Picture, if I'm not wrong. So he's giving us a couple of different files that we can use for our application, which is kind of cool. I've downloaded them into something called my sandbox. So that's something that I've put together always. I have like a little lab 7 part 2 sandbox. I have these two files here, and I'm just going to look at our lab 7.2 and inside of assets and inside of textures, I'm going to drag and drop or copy paste the D7. So copy there and put it inside of, put it inside of this one. So here. And so it's there. There's the D7 small. And the same thing with my Klingon music. There's that, copy that one, going to assets and going to audio and populate that in there. So there we have those two pieces. Those are the two new files we have to add in. And that's what my hint was about the Star Trek The Motion Picture, because it was right there in the album. That's pretty cool, Klingon Battle. And that's the first part. And let's make sure that we launch that again. So again, desktop, going to go into this, GAME3001, section 400, lab 7.2. And I think we're ready to start now. So I'm going to double click on that file to start it off. As always, what I want to do when I start off this whole thing, okay, interesting. I never got this one before, but that's okay. So I have these files open. I'm just going to close all of these off right now. So close all. And what I want to do is run it, and let's see if it, the way it works right now just works. Okay, so that's what I want to do. So first thing we try is we make it work, right? And then afterwards we can add more things to it. So does our lab 7.2 work? What do we have? Also a reminder of where we left off last time. So that's what I'm doing here. Okay, and you should do the same. Make sure that yours is buildable, because we don't want to assume that your copy is buildable if you downloaded it from GitHub or whatever, and yet it doesn't work. Okay, that would be a bad situation. We're also going to say that this is the last day of March, which is interesting. So that's what we're doing here. And tomorrow is April. I can't believe it. So fast. There it is. So this is what we had last time with a little NCL. This is the Reliant, and they're kind of circling, and they're going to, kind of get a bead on our ship. So anywhere where they're going, where there's a kind of a line of sight, our new ships that we're going to make are going to stop and kind of make a line between the first line of sight node and the target, and they're going to attack. Yeah, that's the idea behind it. All right, cool. So that is what we're doing. But now what we have at this point is this old stuff. We're going to start with what Alex has asked us to do in our checklist. Let's go back to our checklist. And again, we've done up to about here. We used our lab 7. We kind of did this. We have to add the move to range action state enum. So that's up here in enums. And inside of the action state, we want to add a new one, which is move to range. So we're going to put that right here, move to range. All right, there we go, that's in there. And that is going to go with what we have. Comment out the build tree function in decision tree.cpp, and then remove all references in decision tree and placing.h. Okay, no problem. So that is, let's close this one off. Nice. And inside of the decision tree, which is inside of the decision filter, so under core, we have a decision tree.h. And what Alex has asked us to do for this round is just comment this one out, which is going to make it so that the build tree method, which is inside of decision tree.cpp, is also in the areas that it needs to be commented out. We're just going to remove it here for now. And we're going to put this up on GitHub, and later on we're just going to remove those references altogether. So this whole part right now needs to be commented out. That's the build tree method of the decision tree class. Okay, so that's what we're going to do there. So comment that out. Nice. Save. So he's asked us to do that and those two functions and those two pieces. And then inside of the placing, so placing.h, we also had a decision tree in here. We're just going to comment that out. For now, we're going to come back later on and remove it. Save. But this way we'll track it, the comments. And anything else that has decision tree in it, like this, we're going to just comment out. So comments. And here as well, comment those out. And again, when we come back to this, we'll remove them. All right, so that's it. And what we should do is probably try it out. So let's try this out and make sure it doesn't break anything else. Because if something is broken, we don't want that to happen to us. We don't want that to go on. And if it breaks, we'll know in a second. And then we'll put this up on GitHub. So now the ship won't move anymore because there's no more tree. No, the brain of the ship is gone. Okay, so that's what's happened. We're going to put it back, and we're going to make two new agents. Like I said, a close combat agent and a ranged combat agent, which is pretty cool. All right, that's good. That is what we need to do for up to here. So we're going to do our first commit. Okay, and let's do that now. So I'm going to bring up GitHub Desktop, and we're going to go to section 401, right? So we're going to go back to section 400. That's you guys. And we're going to say added project files for lab 7, part 2. Okay, so commit to main and push when it feels like committing. Next semester, for sure, I'm going to just use GitHub Desktop. It's been really confusing this week, this semester. See, I'm even confused now. All right, so that's what's going to happen there. Lots of little things. One thing I've noticed, though, with this new way of doing things is our repositories are huge, right? But it's okay. All right, so that is the first part, and now comes the next part. So once we've done that piece, now we're into this part right here, where we're changing our agent.h. There's a lot of changes in this one, so let's get to it. Okay. So back to the drawing board. Let's close off all of these again. I like to try and keep this all clear as much as possible. Agent.h is inside of our core under decision. So agent.h, agent.cpp. And agent.h, what Alex has asked us to do is include a reference to the obstacle class, because we're going to use it as a reference when we create our some of our new structures. We're going to do that in a sec. That is not what we want. Let's close that one off. So yeah, so agent.h. So let's start from the top. So agent.h adds an obstacle right here, right? And also, we're probably going to need the event manager, so let's add that in there too, please. Here's eventmanager.h. Okay, so eventmanager.h is something that we're going to be using with this one. And we're going to check to see a couple things. One also is that right now we have our, again, getters and setters for our actions. And as we go down, we have our action states. We have our set action states. And underneath that, this is where we're going to add in some new tree actions. So new tree actions that will be overridden by the agents, right? Will be overridden, I always spell this wrong, by the agents, right? By derived agents, or whatever they are. For example, example would be the close combat enemy and the ranged combat enemy. I'm putting them here so you understand. So they are virtual functions. Virtual means we can override. So virtual attack, right? And we're just defining a bunch of the actions, all the actions that are going to be here that we can take. So I'm just going to kind of copy paste them. There's going to be 5 of them that we have right now. So there's attack, there's move to line of sight as an action, there's move to player, there's move to range, and there's patrol. So those are all the actions that our agents, the derived agents, will make. The other one is that we're going to have a new utility function, for part 2, lab 7 part 2. And the new utility function is going to be basically like the old agent line of sight to target function that we have already. So it's going to be called check agent line of sight to target. And it's going to take an agent reference as well as the display object reference, which is the target object, whatever we're looking to find, as well as a standard vector of obstacle objects. specifically, right? And we're going to pass in obstacles. So that's what it's going to be. So the check agent to line of sight is going to have an obstacle list, which is our contact list, and you're going to check between the agent and target, and if there's any obstacles in the way, then you don't have line of sight. That's how it basically works, and that's how it's continuing to work right now. So that is our functions that we have here. And for the rest, all the stuff that's inside of agents is pretty much the exact same. Nothing else changes down here for now. What we want to do is let's in place this kind of function right now, and I'd like to generate it, right? So this is our generated function. And if you remember where check agent line of sight to target comes from, right? We already have this function somewhere else that we can write. Okay, so who remembers? I don't know if any of you remember from last week where we had written this function before, right? So remember we had our placing.cpp. Here's our placing.h. Placing.h has check agents, a bunch of check functions, right? So check agent line of sight, and then, which is very similar. Take a look, agent with our display object, and there's also check path node line of sight, right? So it's going to be this one. Let's go to definition for that one. Go to definition, and we can see that this is kind of what we want, but instead of having our a list of contacts, our contact as a display object list, we're going to get it from the obstacles. That's what it's going to be. So just going to go back to our placing.h just to make sure. Yeah, we still have that in there too. So I'm just going to go into the agent CPP now, where we have this part, and fill in the blanks. So I want to grab it from placing.cpp. So grab this whole function inside, same one, copy it, and go into my agent.cpp and paste it. Now there's going to be things that don't compute. And what Alex has done is he's refactored this function right here so it works a little better. Okay, so we're going to get to this in a bit. So one is, let's grab and move this one away. And let's continue with how we're going to write this thing. So a couple things here. When we start off, we're going to say auto, we're going to calculate the target direction, right? And the target direction is going to be equal to the target object, right? Dot get transform dot position, right? And we're going to subtract the agent get transform dot position. This gives us a vector between the target object and the agent, and it's the entire magnitude we're seeing, a line basically that's being drawn, a line segment, right? And what we want to do here is we want to have our normalized direction, and we want to say that is, we're going to use util normalize, and we're going to pass in the target direction, right? And what normalize does, if you look it up, is basically it kind of returns a unit vector that represents the direction that we're looking in, right? That's what it does. So that's my normalized direction. And then I'm going to set the set middle line of sight endpoint. That comes from the agent class itself that we've had. Remember, the agent class has a middle line of sight endpoint and a right line of sight endpoint and a left line of sight endpoint for the whiskers that we had in a previous lab. So we're going to get transform.position, that's where we're going to start off, plus the normalized direction multiplied by the get line of sight distance, and that's going to give us a line of sight from our agent to the target, and as far as we can. So if we're going to point, we're always going to be looking at that is going to be the direction to the target every single time. And that's going to give us almost like a bead or a line that we're going to attack from, almost like a line of attack or an angle of attack, if you will. All right, so that's the first part. This stuff stays the same. Agent to target distance is the exact same, right? And this part is the same. If our agent to target distance is less than agent line of sight distance, then we want to have a contact list of display objects. But instead of looping through each of the something in the display list, we're going to loop through each of the obstacles. And the obstacles are something we're going to pass in here. So obstacles is what we're going to put in here. And I know it's called objects. So every object, we're just going to rename this. For me, I'm going to rename this to obstacle. So refactor, rename, and this will be the obstacle. For every obstacle in obstacles, that's how we're going to say it. Alex may have left it as object, and that's totally fine. So it's no real difference. Agent to obstacle distance is going to stay the exact same, right? Now the next one is if agent to object distance is greater than agent to target distance, continue. So this is a continue, right? And I think we have a continue here, this continue. And the next part is going to be removed. So this part is no longer there, right? Instead, what we're going to say is the contact list dot pushback, and we're going to push back the obstacle. Okay. And it says to add collision manager. Yes, we will. We'll make a reference to the collision manager here. And what it's saying is, so now that the for loop is done, we did this part. The agent endpoint isn't really something we need at this point anymore. Let's get removed. This is a part of the refactoring that Alex has done because we already have that. And we're going to calculate the has line of sight. We're going to update the has line of sight Boolean with a line of sight check between the agent. Let's just put this on one line. And instead of the agent endpoint, we're going to use the get middle line of sight point, right, which we've kind of used. So again, get middle line of sight endpoint, right, the contact list and the target object. And we're going to move this agent set has line of sight outside of the if statement to down here, which again is another refactoring. And that, my friends, is the new version of our check agent line of sight to target. Yeah. Let's just remove some extra spaces here. Okay, for the people that are here, are you with me? Are you with me on this one? So again, all I've done is I've taken the stuff from the play scene and refactored it and put it here. Later on, we may remove the stuff from the play scene. We'll see how it goes. So guys, are you there? Are you with me? Okay, thank you so much, Tarif. All right, so now that once we've done this piece, let's go back to our checklist. So I always kind of go back and look and see where we're at. We built this, added some virtual functions, we added the prototype, and we also filled it in. That's what we did it, and now we can do a commit. So let's do that. So we'll say here we updated agent class. All right, so commit to main and push, nice and easy. Awesome. All right, now the big work. And this is where a lot of my time was spent in the earlier class, close combat enemy.agent.cpp. We're going to make a copy of the spaceship.agent.cpp for now. Let's do that in the operating system. So again, I've got my operating system files here. I've opened them up. I'm going to go into source, and I'm going to grab the spaceship.h&.cpp. And I just find this is just a way faster way of doing it. So spaceship, so copy and paste. And we're just going to rename these things to close combat enemy. Close combat enemy.cpp. And this one will be the close combat enemy.h. So make sure they're spelled correctly, close combat enemy.h and .cpp. And then what I'm going to do is go back into the into Visual Studio and load them back in. So going to agents, right click, add existing item, and I'll add those two back in. So here's in our SRC folder. Just going to grab those two files, close combat enemy, right? Those two parts, and make sure that they're the right pieces. There we are. And then add them in. Woohoo! Now they're obviously wrong, right? Because they also say spaceship. We need to change this. So if you click once on it and Control F, we can say that we want to change spaceship to close combat enemy, right? So Let's try that. So close combat enemy with spaces in between. We want to replace all in the current document. We've done that. 3 occurrences, 1, 2, and 3 down here. That's what we changed. We also want to check this one, and then, so let's just close this one up, check it, and Control F. Spaceship, we want to change spaceship to close combat enemy. Close combat enemy. And we're going to replace all that too in this document, current document. All right, so that's what does it there. That's good. So far, so good. Save. And now we want to go to the close combat enemy.cpp immediately and change these. So again, I'm going to select spaceship, Control F, and replace it with close combat enemy, right? And replace all. This will even replace the reference to the .h file, which is pretty cool. Awesome. Excellent. So now we have close combat enemy.h and close combat enemy.cpp. Okay, excellent. Now that we've renamed everything, we need to do some additional changes, right, as we continue forward. Okay, let's go back to our checklist. Checklist. So we've done this, right? We're not going to make the ranged combat enemy yet because it makes sense to wait. In the decision tree, we need to include that in the close combat enemy class, because we're going to include the decision tree as the brain of the enemy, like we say, right? So let's do that next. So again, we're going to include that here. So decision tree. There it is. And down, pretty much all of this remains as is. But when we go down, we can see that there are a couple of new actions we need and all that. But first, we start off with a decision tree reference as a private member. So we're going to say, let's add a decision tree here. And we're going to say that, hey, decision tree, we want to add in this tree called m_tree. And we're going to do m_build tree. We did this before. Remember that build tree function we commented out? We want to have it here inside of each of our agents. Okay, cool. Save. And up in our getters and setters, we have our get max speed and get turn rate, all this kind of stuff. And we also have a seek and look where you're going. Underneath that, we're going to have some new actions. So new action functions related to the close combat enemy. There's some that we're not going to do, but for now, the new actions are a void patrol. We're going to override that one. And we're going to also void move to, you can see that they come up as part of our superclass. Move to player is what we want, and we're going to override that one. We're also going to return a reference, right? So we're going to say const decision tree, and we're going to return a reference to the tree. Okay. I'm just going to make that into a separate thing here, but you can certainly make it what Alex did, which is inline. I'm going to add that, generate the implementation here, and just return the tree. Reference. And also it's going to ask me to make this const. Oops. Makes this const. So we're going to ask me to do that. Let's do that. Awesome. And back to the .h for a second. It's also going to ask me to do this. Let's make a stub for this right now. So generate. There's our stub. And of course, what are we going to have in here? Stuff that we had from build tree, from the original function in the decision tree class. That's what we're going to have in here eventually. There's still more work to do. So that's the first thing. We've kind of set up our .h, and we've kind of put together our .cpp, and let's follow the notes. Okay, so again, we did this one. We'll like the brain, add public methods for a few actions. We did that. Add a getter for the tree. We did this. Add a private decision tree pointer. We did this. Okay, and in the .cpp, add all the includes for the tree. Now this is important because we're going to include new actions that are related to this close combat enemy. So let's do that next. So that is, and even though we don't need them all, we're going to put them in anyway. right? So at the top, way at the top, we have a bunch of actions that we're going to need. We can also generate these actions automatically, but why not just put them in now? So include the attack action. Okay, we know we're going to do that. We're also going to include the move to line of sight action. There we go. And finally, we're going to include the move to player action, right? Because we're going to attack in close combat. And we're also going to include the patrol action. There's those actions we're going to add eventually. All right, so that's those are includes. Back to this. So now that we've added the includes, change the texture to be the D7 because that makes sense and it's a good day to die. Kapla. Yes, kapla, my friend. Let's do that. Let's change the texture. So the D7 is the new one we just got from our little sandbox. Let's do that next. So that's in here. So this is going to be the D7 small instead of the Reliant small, D7 small. We're going to call this, change the name of the reference we're going to store in the texture manager to close enemy. Again, this is key value pairs. We're going to store the texture in the texture manager and have a friendly name for what it is. That's how we've worked it out. So I'm going to copy this as we're going to get the size of the texture here. Nice. All of this remaining stuff is more or less the same. The patrol action for us is going to be the same, right? And we also are going to have a set target position the same, and the set agent the same, but we're also going to make a reference to the tree here. We're going to say that let's create the decision tree, and m_tree is going to be equal to a new decision tree where we pass in a reference to this. What is that? Well, that is the overloaded constructor function that Alex mentioned last day. We talked about that as well. And what is this? Well, let's take a look at decision tree. Go to definition for a second. And you can see the decision tree has two constructors, an empty constructor as well as one that takes an agent. And what we're doing is we're passing in a reference to this object, this agent, which is our close combat enemy. Okay. Also an agent. And then finally, we're going to, if you want to, which is not a bad thing, first we need to build the tree. We're going to do that in the constructor function as soon as the agent has been constructed or instantiated. And then the tree, we're going to display the tree. And this is kind of an optional feature if you want to see the tree or not. What is the tree? Feature functions. Maybe we'll actually display this in IMGUI. We'll see how that goes. I'm being ambitious. All right, so that's this part. And like I said, we just modified these and we added this part up here. Let's copy this close enemy here. And we're going to print it out in our draw function, make sure that this is close enemy and not spaceship. So the line of sight thing is something where we want to only show the line of sight. This is where our event manager comes in, where we're going to say the only time we want to draw a line of sight is if the IMGUI function is active. So we're going to say, hey, event manager, you are keeping track of the is IMGUI active. You can tell us if it's true or not. Wow. Okay. And what we want to do is remove that part, the line of sight. When we draw our line of sight line, we're only going to do it when we're in debug mode. That's what it does. So draw a line of sight only if IMGUI window is in debug mode. That's the only time I want to draw it. Okay. All right, so this is pretty cool. The update function also must change. So instead of it being here like this, where we did get an action state, instead, what we're going to do is we're going to make a decision. So we're going to say m_tree, and we're going to say make a decision. Okay. Because make a decision, if you follow along with what that is, let's go to definition for that. What it does is it traverses the tree in order. So it starts at the top, and we use a little while loop. And what the while loop does is it goes through each of the conditions until there's no more conditions, and then hits on a final action, depending on which of the conditions you've chosen to. Well, that makes sense. So for example, if we have line of sight, then we follow the right subtree. If we don't have a line of sight, we follow the left subtree, which is for now patrol. Okay. All right, so that's what this does. And let's make sure that that decision tree is saved. I'm just going to go back one. So let's make decision. And clean doesn't do anything. Max speed and all these getters and setters are the same. Seek is the same. Look where you're going, no change. Get tree is something that we can update, right? Get tree returns a tree. That's what we did. The move function, well, that doesn't change. And we need to define the other actions, the patrol action, as well as the move to player action. Let's do that by going back to combat, close combat.enemy.h. And we have these two actions. Let's add them in. So we're going to just do, I want to generate the implementation. I can do that by going to this, the name of the class, and then going to generate definitions by declarations. We're going to have those two to generate, and they get generated here as two stubs. And then we're going to say if the get action state, I'll be okay. If get action state is not already equal to patrol, then put me in patrol, right? So we're going to initialize the patrol action, right? So we're going to set action state to patrol. And we'll talk about what that does. And then in patrol, for us, when we do patrol, we're going to move, right? Similarly to this, if we're moving to player, right, then instead of patrol, we're going to check if the action state is move to player. There we go. And then we're going to move to player as an action state initialization, but we're not going to move yet. We're going to comment this one out. So that's for next week. All right, good. What is set action state do? Do you remember this one? Go to definition. Well, set action state, right? All it does is whatever the state is of the action, it's going to set it and store it inside of m_state, which is in the agent itself, right? So it's going to store state. And we're going to keep track of the state here. Okay, nice. Let's go back. So that is the patrol or the move to player state, depending on which one we're in right now. Those are the two that we've defined. There's other ones we haven't defined here, like radius. Do we have, are we within radius? There's other actions that we haven't taken too. The patrol action, move to player action, move to line of sight action. We don't have a bunch of them here that we could add in, but we're only adding these ones in for today. Okay. So the move function doesn't change. That is kind of the same. Then the big one that changes right now is this build tree function. But in order for us to do the build tree function, we need to do a couple of things, okay? And a couple of those things are we need to change or add some setters and getters, right, to the decision tree. So back to the decision tree. Let's get that before we start even in here. We're going to go back to the decision tree itself. So that's in core. And let's go to decision tree.h. And so far, what we've had in the decision tree.h is a bunch of getters. Well, we need also to have some more setters other than just this one, set agent. Okay. So we have we have a bunch of getters like get agent, get line of sight node, get radius node, get close combat node, but we should also be able to set them now as well. All right, so that's the thing that we need to do as well. All right, so let's go to that and start, adding some setters. So we have get agent, get line of sight, get radius node, get close combat node. In the future, we're also going to have a ranged combat condition. We don't have that. I'm just going to pencil it in right now. So this is going to be a ranged combat condition. This is for next week, where we're going to get ranged combat node. Okay, we're not going to do it yet, but we're going to put it in here for next week. All right. And then we're also going to have return a vector, a standard vector of type tree node pointers, right? And we're going to actually just use that as get tree. So we want to return the entire tree from this function. All right. And the reason why we want to get reference to the tree is we want to have access to the tree node list, as you'll see in a few minutes. So before set agent, because that's get agent, we could, or after get agent, set agent, we're going to have a bunch of setters. We're going to say void set line of sight node. where we're going to set the line of sight node to the line of sight condition, right? Whatever that node happens to be. We're going to void set radius node. We're going to set the line of sight or radius condition, sorry, radius condition to the node. There we go. We're going to void set close combat node, where we're going to have the close combat condition. We're also going to void set range combat node. We don't have this yet, but we're going to have a ranged combat condition. Again, this is for next week. And we're just going to comment this one out for now. Okay, and that's really them. So really we're going to have is set line of sight, set agent, set radius, and set close combat. So those are the ones we have. And let's define what those are really quickly, because we want to make sure that these are all correct. So we got our getters, but we need to make our setters happen as well. I'm just going to make sure there's nothing else we have to change. I don't think so. And let's just make sure we do that. So we're going to say generate definitions by declarations. Those are the new ones we're going to add. Finish. And we start off with get tree. So get tree, we're just going to return a reference to the tree node list, right? That's what the get tree method is going to do, right? So we're going to say return m underscore tree node list. That's going to return a reference to that. We're also going to return, actually, sorry, this is setter, m underscore line of sight node is equal to node, right? And we're also going to have m underscore radius node is equal to node. And then finally our m underscore close combat node, close combat node is equal to node, right? So that's what we've done here with our getters and setters. And for the most part, our decision tree is pretty good. We don't need this build tree, but we're going to keep it for a second because I'm going to copy paste this into our close combat enemy in a second. Okay, so that's but we have to fix this out first because, you know, there were some things that were missing. And there's all these underlines, and they're probably going to tell me insert no discard, modernize, use no discard, apply, you know, tiny fix to the whole file. I'm not going to do that right now. Okay. So again, we don't need this. We can probably get rid of this because we don't need it. We don't need a reference anymore. And we're going to get rid of the other thing in a second. But first things first, I want to copy what we have from our decision tree.cpp. So this whole piece in here. And I'm going to grab it all, because this is what's moving. This whole thing is moving to our close combat enemy.cpp. So right in here. And we couldn't have done that until we set up those nodes, because the way this is going to be formatted is going to be, well, a little different than what we had before. All right, so you can see clearly we have some issues, but it's not a big issue, nothing to worry about too much. Where we say anything like line of sight node, right? Anything like this, I'm going to replace, so Control F. I'm going to replace anything that has line of sight node with m underscore tree. And then it's going to be, there, yeah. I meant, let's go back in there. Almost made a mistake. What this is going to be is basically we're going to, you know, have a new thing. It's going to go m underscore tree, and we're going to set line of sight node to this, a new line of sight condition. So an empty one of these. And I'm going to do that a couple places. So again, m underscore tree is set radius condition, set radius node to this new radius node. Hold on tight. And m underscore tree, I'm going to do these first, is going to be set my close combat node to a anonymous close combat node. All right, so that's going to go there. And where it says the tree list pushback, so this tree list, Control F, what we're going to say is anytime we say tree list, we're going to say m_tree, and we're going to get tree. I did it again. Tree list. I want to replace with m_tree and get tree, right? That's what I want to replace it with. So let's replace all of those. Cool. So a lot of those happened, right? And the same thing with line of sight node, it's going to be get line of sight node. So let's close this off, click onto this, Control F, and we're going to say that let's replace m_ line of sight node with get line of sight node, right? So we'll replace all those. So again, this is going to save us some trouble. Let's undo that change. I need to put in the brackets. Erg. Oh, I hate those changes that come up. Let's redo. Thank you. Redo. One more time. All for the love of copy pasting, eh? Replace this with m_tree. Get line of sight node. And replace. Right. Get radius node, same thing. So whenever we have get radius node, we're going to say replace with get radius node. I'll be okay. And same thing here. So we can go here, Control F, and get close combat node. All we're doing is we're restructuring everything so that way it works. Anytime we see agent in here, m_agent, we're going to replace with, and this is the entire document, so we have to be very careful of the replacements we're making. I could also do this whole selection, but add node, this add node function right here, that's going to be replaced with m_tree add node. So we're going to say add node, replace that with m_tree add node. Actually, let's do that. There we go. Replace all. Good. And anytime we see agent, let's replace this with this. So this is going to replace here, because we're setting the agent to this agent right here. And we're using dynamic cast because it's not giving us any errors or any warnings. Let's make sure I'm going to scoop through this thing to make sure it's the exact same thing. So line of sight condition, radius condition, and close combat condition. The left tree and the right tree, we're using our get tree pushback close combat node and get radius node and get line of sight node. These all look good. Actions, so those are the conditions. Let's just space that off. And these are the actions. So tree node, patrol node, we're going to add a node to the tree, which is the get radius node with a new patrol action. And we're going to do a dynamic cast of site agent this. We're going to push the patrol node to the tree. So every time we do a get tree pushback, we're actually building the tree. This is what builds the tree, these lines here, right? With whatever the action nodes are, or the condition nodes or the action nodes. Again, not a lot of condition nodes. So set line of sight node is the top of the tree, right, as an example. And then what we're going to do is keep on pushing back all the other ones as we keep going. All right, very good. We don't have a very deep tree right now. So again, we're going to have a couple of additional things here. We're going to have all of these actions pushed back. We don't have a move to line of sight action. We don't have that yet defined inside of our close combat agent, but we were going to do that. All right, so that is this piece. The build tree is done, and let's just save all. So we're going to make sure we save all, and I want to go back to the checklist. Let's go back to the checklist. So, okay, we changed D7. In And the draw only the line of sight. If you've filled out all the bodies yet, we filled them out. Build tree will take some time, but you can paste it in from placing. We did that. In order to make build tree inside the agents, you'll need to setters in the decision tree class for the nodes. We did that, and we need to commit. And we pretty much finished off our close combat enemy. So let's do that here. So we're going to say completed close combat enemy version 1, because this next week we'll have another version of this one, and push. Awesome. And now that we've done this, we have a good template for the next enemy. Let's just close all these down. So close all. And again, what I'd like to do is in the operating system, take that close combat enemy we just made, and copy and paste it. And we're going to make a copy of it, which is the ranged combat enemy. So again, we're going to say ranged combat enemy, ranged. And the same thing goes with our other one, the .cp, the .h. And of course, what we want to do is add existing item, and we want to select the ranged combat enemy, these two things, inside of our code. Now, caution, a couple things. What I didn't do with the last group was I forgot to change this one. You need to change your defines, or else it's going to see this thing as an extension to the class. We don't want that. So again, I'm going to click once in there, Control F, and we're going to change close combat enemy to ranged combat enemy. Please do that right now. Okay, for the current document, we want to, so I'm getting ahead of myself. We want to change this. Ooh, one of those days today. Ranged combat enemy, and change all. There we go. So that is 3 replacements. Awesome. Okay, that's number 1. 2. Okay, 2. Let's change every reference to close combat enemy to ranged combat enemy. So ranged combat enemy. It has, keep on doing it. See what happens. And Alex put all this cool music, and I'm like, you know what? I got distracted. I got to blame somebody, right? I should really blame myself, but the cool music. Ranged combat enemy and replace all. And that replaces 3 replacements inside here. We're pretty good. And we're going to save this piece and move on to the next file. So ranged combat enemy.cpp is next. I'm just going to pull it over here because I like having my .h on the left. And I'll do the same thing. So just click onto that and replace it with this, replace all. Those are all the replacements, 23 replacements there, including the include. That's pretty cool. Now this is going to go back to the reliant. So the ranged combat enemy, we're still going to use the reliant small. So we're going to change this from a D7 back to the reliant, right? And we're not going to call it, and this is in the CPP, we're going to call it the ranged enemy instead of the close enemy, because the ranged enemy is going to be held in a different spot in the texture manager. So this is ranged enemy. And we're also going to change the ranged enemy referenced here. Okay, so this is inside of the draw function. So far so good, and it's the exact same. So pretty cool. The exact same enemy, no problems. Now, what we also want to do is with the ranged enemy, we want to start using the, instead of move to player, we want to move to ranged, right? So again, I want to change this to move to range, which means I have to rename the function in the CPP. I did it differently today and it really messed things up. So I'm doing it this way. So move to range. There we go. And instead of move to player, it's going to be move to range. That's the one we just added this week. Everything else is the same. We're not going to do a move function. And that part is done. Nice. So far so good. We've just renamed it and we have our ranged combat enemy. Let's go back to the checklist and make sure we continue. So we made a copy. Yes, we did. We made a duplicate of it. You only need to make a few changes in the build tree function, and we have to, instead of move to player, we change to move to range. That's nice, and that's excellent. Now we are missing some stuff, and I think we got everything. The move to range action is something else we need to do. We don't have that action. And there's some changes to all the actions that we have to make at this point now too. So let's do that next. So I'm going to go into the operating system, and I have a bunch of actions. I have move to line of sight action. I'm just going to copy these two actions, copy paste. And instead of move to line of sight action, I'm going to say move to range action. So in the .h, move to range action, and move to range action.cpp. So I'm adding those two actions, those two files, and then back into the code, back inside our code. Then what we want to do is we want to add those two actions in here under actions. So right now we don't have a move to range action. Let's add that in. So add a new or an existing item where we're going to have a move to range action, move to range action.h and .cpp. And maybe we can kind of select the right ones. There we go. And add. Cool. Move to range action. Well, we have to reset what this says. So again, Control F. We're going to move from move to line of sight action. I'm going to change the name to move to range action. Right? And we're going to replace it all in this document. There we go. That's important to do. And the same thing goes here. We're going to change this to move to range action. Right? Replace that in the current document. Excellent. And we're going to go back into the move to range action.cpp. We're going to select that one. And we're going to replace everything in this document as well, which changes all the references. Now, this is where Alex has made some changes, and we want to make sure that we adhere to some of these new changes. Move to range action. We'll start with this one. And nothing in the CPP, in the .h, but in the CPP, it's slightly different. It's going to be an if statement. If get agent, and we're going to look at get action state. If the action state is not equal to the move to range action, move to range action, right? If that's not true, then output it, because we don't want to output this unless we're inside of that other state. And then we're also going to get the agent that is related to the move to range, whatever the agent has set up. So if the close combat agent set up a move to range action, it's going to trigger that action. That's what's going to happen. All right, cool. So that is this piece. And this structure, for the most part, is going to be something we're going to copy paste. It's the exact same every single time, but instead of move to range, we're going to call it something else. So copy this. And what I'm going to do is I'm going to go and check all of them. So patrol action, what does that look like? Kind of similar, but we're going to do it like this. So we're going to try to put that out there. And this is patrol. And this will be patrol, right? So this is the stuff that's going to change. Right? And we're going to change them all. So we've changed move to range. We're going to change move to the player action. We're just going to replace this part with this. Move to player. And this is move to player. Okay. And same thing goes with move to line of sight. These are just things we have to change. Move to line of sight. There we go. And move to line of sight. Okay. So we've done all those. Last one is move the attack action. Same thing. So attack and attack. Now, I'm not sure what we're going to do next week, but attack, there's two types of attacks. There's a close combat attack, and there's also a ranged attack. Maybe we'll decide, depending on the on how we're going to override this thing in each of the in the enemies, the ranged combat enemy versus the close combat enemy. Let's save all, please, as we've added this in. And now that we have our move to player action, and we also have a move to range action. Once we have that, then we can modify our ranged combat enemy.cpp, where instead of having our the set close combat node, you know, as an example, we don't have a close combat node inside of the ranged enemy, right? We don't have that inside of the builds tree, right? Because that doesn't make sense. We're going to have a set ranged combat node, set ranged combat node, ranged. And if we don't have this ranged combat node, then we need to set it up, right? We need to set up set this ranged combat node to the ranged combat condition. We don't have a ranged combat condition at this point, right? So that's something that we're going to need to change. So ranged combat node, remember a setter and a getter? We don't have this stuff yet for the ranged combat condition. So for now, I'm going to comment this part out. It's not going to really work without it though. So, yeah, I kind of left it in whatever it was before. I didn't change this the last time because this is something that we're going to have to add in. We haven't had that in yet. That's the close combat node. We haven't got the range combat node yet. That's one thing we don't have. Not yet. But we do have instead of move to player node, that's an action. We're going to have a move to range node. So this is a move to range node. Move to range node. And the move to range node is going to be tree, add node, and then we're going to get I think it's still the get radius node. Let me just undo that change. Get close combat node. Yeah, we're going to have to do the change. We can't do this without, sorry. I don't know what I did earlier, but I didn't do that. All right, so move to player, move to range. This is move to range. Move to range. Let me just go. Maybe he had that in the notes. I'm just you know, getting a little faster than myself. Yes, he did not. Okay, so let's add those things in. We were going to make them in as a something we're going to add next week, but it's okay. So the close combat condition. So we have a close combat condition. We need a ranged combat condition. Without that, we can't really do a ranged combat action. Not really, right? So let's add those in too. So again, I'm going to go back to this. And the close combat condition is right here. We'll just copy them and Control C, Control V. We'll add a ranged combat condition. Yep. Ranged combat condition. Sorry, I'm just looking at this, making sure that it's correct. Ranged combat condition and a ranged combat condition .cpp. That's a bit of a difference there. I think we got time. There we are. Ranged combat condition. And we're going to add those in. So let's do the same thing in the conditions. We're going to just add in a new existing item, which is the ranged combat condition. Ranged combat condition. Add. And the ranged combat condition is same as the close combat condition, right? But with some changes. Let's change the names. So Control F. Close combat condition. We're going to change this one to ranged combat condition for the entire document. Nice. And of course, we're also going to have to change this. So this will be the ranged combat condition. Ranged combat condition. Replace all. Nice. And we're going to have a setter that is set is within ranged combat distance. That's something that we're going to need there, right? So set is within Well, we can kind of call it the same. Set is within combat range because it is within combat range, just ranged combat as opposed to close combat. And that means that the is within combat range state is the exact same thing. The only thing we need to do in the ranged combat condition.8.cpp is rename stuff. So we're going to just go Control F, and we're going to change it to this, replace all in the document, and we're going to change this from close combat condition to ranged combat condition. Okay, I think I got everything. Okay, good. So that I didn't need to do that, but I did it because in the decision tree, let's go back to the decision tree. In order for me to fix up, I need this ranged combat condition, which is something I got to add in here. So I'm going to include in the decision tree ranged combat condition.h, right? And then I'm going to kind of push those two things in there. Get ranged combat node and set ranged combat node. And now that I have those two pieces in, that was supposed to be for next week, but I'll do them this week. It's okay. Well, we can't really do the range. I don't know how I did it today. Thinking about it now for the other class, but I can't really change the ranged combat enemy without them. So that's that. Let me save all. And let's close all of these for now. Close all tabs. But let's open up the ranged combat enemy and the enemy.cpp. Okay, let's fix those problems. So again, we saw that we can't really do the same. There's not the same tree as before, right? We don't have a close combat node anymore, right? We have a ranged combat node. So that's where we're going to have a difference, right, with what our thing is going to be. So we're going to say that instead of set close combat node, we're going to set ranged combat node, right, which is the ranged combat, new ranged combat condition. There it is. Ranged combat condition is going to be in place. We're going to add node to the line of sight node, and it's going to be the, instead of the get close combat node, it's going to be get ranged combat node, where it's going to go for the tree. Just going to make sure that this is good, and this is also going to be get ranged combat node. In fact, I can probably change all of the instances of the close combat node to the ranged combat node. Let's do that too. So let's change this one. I got to do it here because it might mess up my entire document. So let's just do that. Ranged, and that's pretty good. Now we need to move to line of sight node, move to player node. Move to player node can't be the same. I'm just going to make sure that this is good. Ranged combat node on the right side, because if we're in line of sight, to the right is the ranged combat node, and then from that we have on the right side, the right tree, we have move to line of sight action, and then instead of move to player action, we're going to have a move to range node. Move to range node, that's what it's going to be called. And the move to range node is going to be the thing that I'm going to use. And it won't be the move to player action, but rather the move to range action. And I can't do the move to range action because it doesn't exist. Move to range action, move to line of sight action, right? I could add this in there. There's my .h that I added in there, right? Move to line of sight action, we had to add in. Move to range action, right? Move to range action, we had to add in. That was something we had to add. And that is basically how it would work to make sure nothing else is clashing. Move to range node, attack node will be the same. Line of sight node and patrol node. And all those things are pretty much the same as the other ones. I've just added in the range combat condition. And that's got up here, it updated. We don't need a move to player action because that's not going to be something that's part of our ranged combat enemy. Woohoo, right? All right, and let's test all of the stuff we've done just by doing a quick build. There's nothing being called right now, but if there's any syntax errors or anything like that, At this point, I think I'd like to know. Visual Studio Code is going to, Visual Studio, sorry, is going to tell me if there's any issues. And let's try this out. It shouldn't. And if there is, we'll see where the problem is. Okay, so it says unresolved public range combat condition and unresolved a link to range combat condition. So range combat enemy, range combat condition, and let's see where that is. And if I'm wondering if ranged combat condition is in the decision tree, that's where it should be. Let's go into that decision tree. Ranged combat condition is here. Close combat condition is here. Radius condition is here. Let's go into the, let's go look at the close combat enemy. Control action, attack, move to line of sight, move to player, move to thing, move to range action. I wonder if it's there. Move to range action. Move to range action. Move to range action. Move to, this should say move to range action. Yeah, so what is that that's causing me to have an error in the ranged combat enemy? Decision tree, range combat enemy. And we've got the decision tree in there. Move to range. Move to range action. Range combat enemy. Sorry, just to save all and run again. Where's that error? Resolve external symbol public class ranged combat condition. In the decision tree. Range combat node. I'm going to clean our solution and try that out again. Sorry, just want to make sure that I didn't mess things up. Range combat, move to range action, move to player action, move to range combat condition. Why? Close combat condition. Okay. They haven't been linked somehow. Range combat condition. All right, so range combat condition is looking through the range combat enemy that's in here. So let's go through it. So range combat enemy, we have these actions. Move to attack action, move to line of sight action, move to range action. Move to range action. What does the move to close combat action, move to player action have? Move to player action as an action node, and it has this move to player action. It's performing this one, and that worked okay. For the close combat enemy, it doesn't really have anything in there. We have a, we don't really talk about the conditions in here. And in the close combat enemy, but at CPP, move to line of sight action, move to player action. What about the condition? Wait, did I do something wrong? Ranged combat enemy dot CPP. Maybe the way I instantiated them. Okay. Ranged combat node is a ranged combat condition, a new one. Go to definition, please. Condition node, combat condition, make a new one. That's good. Range combat condition, those things are noted nicely. And my range combat condition dot H enemy, a range combat condition, range combat condition dot H condition node condition is with combat range combat condition dot H. Did I save everything? Ranged combat condition, ranged combat condition. Yes. Huh. Doesn't know how to build it. Am I in the wrong spot? Ranged combat condition .h, ranged, make sure they're spelled properly. Ranged combat condition .cpp. Ranged combat condition .h. Why is this not staring me in the face? So condition node and condition node.h. That's right. We're including it because we're adding a new ranged combat condition. And the new ranged combat condition is going to happen in the ranged combat enemy. Ranged combat enemy is going to the decision tree, and the decision tree, let's go back to the decision tree for a second. Decision tree has a ranged combat condition that's included. So if I include the decision tree, I also include this ranged combat condition. And I have a ranged combat condition getter. I get one, which returns this and set, oh, duh. We never define what these are. Let's do that. All right, that's see, I trace it and I can figure it out eventually. Yay. We can't do this unless we do it. So the getter is going to return m underscore ranged combat, the ranged combat node, but we don't have these things, right? We haven't set them up in the decision tree. Oh yeah, we set up the thing, but in the .h, we didn't set up any of these things. So we need to have a ranged combat condition, m underscore ranged combat node. Yes, we can't do that without. I'll be okay. That's what happens. And then, yes, okay, excellent. Nicely. I'm glad that we figured it out. It only took me 10 minutes. And return m underscore ranged combat node. There we go. And then set, well, we're going to say that m underscore ranged combat node is equal to node, which is going to be exactly what we want to do for the getter and setter. That should fix the problem. Turns and then sets. Looks good. Looks good. Excellent. Okay. Looks good. So that updated the tree function, and that should do everything now if I run it. That's why I ran it first. I ran it first, guys, because I always want to check to see all these different changes we made, if there's some kind of issue. And if there is, then we need to figure that out now before we do the next step, because we haven't done that until this point. Nice. It builds. Building is good. Excellent. All right. So now that this is built and everything else, let's go back to our checklist. Checklist. Close combat enemy. Okay, we did this part. We did the range combat enemy. We did the move to player functions. We need to do a commit now for the range combat enemy, because we never did that. Okay, so we need to do that. So we're going to say that added ranged combat enemy version 1. We also added the other conditions in 2 and so on. Let's push that up. Awesome. Great. All right, next, we're into the play scene. So interestingly enough, this is the easiest part, believe it or not, because it's ready to go. Let's just close all these off again, close all tabs, and we'll get into the playscene.h. And in the playscene.h, what we want to do, just going to go in there, is do a couple things. One, the spaceship is no longer needed. We're not going to have this in there anymore, so no more spaceship. However, we're going to add in references to both the, we don't need the decision tree anymore, decision tree.h, goodbye. We're going to include, for this one, the close combat enemy, as well as the ranged combat enemy. This one, okay? So those two things we're adding in. And then where the ship was, we're going to start off with the close combat enemy pointer. And alternatively, what we want to do is, Alex has asked us to test both. So we're going to do that. We're going to say this is the ranged combat enemy. But we're going to comment this out because they use the same name. So we're going to just have one spaceship right now. It's going to be the close combat enemy. Then we'll check it with the ranged combat enemy, and then we'll be done for the day. All right. So that is the .h and the .cpp. So minor changes here, right? So again, what we want to do, we'll start at the top and we'll work our way down. So again, no changes here at the top. In the update function, this is where we have our update list, right? And Alex has some notes in here that he'd like to, I'm just going to copy paste his notes that he talked about in his draft. And basically it's like this. We're going to set the age and tree conditions here. That's what we're going to do. And eventually we're going to replace the parameters with distance checks. We're going to have something like this, m_p spaceship get tree. We're going to get a tree. We're going to get the radius node and set within radius to false. We're going to set up a bunch of stuff here for both the close combat and range combat nodes to make sure, depending on the type of enemy, we're going to initialize. This is all initialization that we're going to do. Okay, so this part here. Instead of doing a m_check agent line of sight check, we're going to, again, something that we may remove later on, we're going to say m_p spaceship, and spaceship is going to be, in this case, the close combat enemy starting off. We're going to get line of sight node like we've done up here, right? And line of sight node, we're going to set line of sight, and we're going to say that m_p spaceship, remember that set line of sight, we're going to use the check agent to line of sight target. We're going to pass in the spaceship, the target, and the obstacles. Okay, so that's what we're going to do there. I'm going to put that over 2 lines so you guys can see that a little better, a little clearer. I'm just going to drop it down from here. Okay, so you can see that. So what this is doing is says, hey, on the spaceship, go to the tree and set the line of sight node to, can I make a check? Can I make a check between the spaceship and the target and anything between blocks line of sight? This is that utility function we wrote that's part of the agent class now. Okay, nice. And then as we move forward in the start function, so here's our start function, we need to change the music. We need to make a few other minor changes. Obstacles are the same, but spaceship is not the same. We're going to have 2 versions, one of them which is the close combat enemy, right? And the other one which is the range combat enemy. When we turn, we're going to check both out. So this is going to be ranged combat enemy. And we're just going to comment this version out for now, right? So we're going to come back to this and try this one out too. And in terms of the music, that's where we change. We don't need this anymore. We can remove the decision tree references. We're going to clean that up in this round. And instead of the Mutara music playing, the Mutara Nebula, which is kind of cool, we're going to copy paste down in here. And we're going to comment this one out. Maybe we'll use the Mutara music some other time. We still have that, right, if we like that kind of stuff. But we'll change this to Klingon and Klingon. And that'll be the Klingon attack music. So maybe what we can do is in a future state, if it's the close combat enemy, we'll do the Klingon music. And if it's the ranged enemy, we'll do the Mutara music. Okay. And that's really it for everything that we need to do in the playscene.cpp. We should probably test it at this point. So let's test it out, and we should see. I think we covered everything. Let's make sure. And there we go. We got our little Klingon, and we have line of sight here as an example, and that's wrong. That's definitely wrong. it had line of sight, but this thing is supposed to turn towards the player. The line of sight line is going to go from the Klingon towards the player. So that's actually incorrect. But what it actually did, it did the right thing. It just didn't draw the line properly. That's interesting. You got to fix that part. What this means is if I move my player around, so let's move my target position, it's going to keep wandering until it can get line of sight with the player. But this line of sight line, instead of being straight on, should actually point to this. So we're going to go back and take a look at that close combat enemy and see what it did, what we coded wrong, right? Because that means it's coded wrong for the ranged enemy too. I did it properly in the first round. And it should stop, right? Because this is where it has actual line of sight where this one would connect. It's just not pointing in the right direction. All right, so let's see what I did wrong. So that's incorrect. It should actually have a line between the Klingon and the player. So let's do that. And that should be, we're drawing a line from one to the other. I'm just going to check the close combat enemy. And the close combat enemy, is it there or is it? It's in both, which means it's probably in the agent. Let's go into the agent. So decision and the agent, agent.h. Remember we added this check agent to line of sight distance. I wonder if that's the issue. I'm pretty much sure it is. Let's go to definition. Go to definition for this one. And what should it be? I'm just going to I'm going to just dull this up for now so we can see this and it's all of its finery. It is what it is, man. Lots of changes. This is what happens, right? So it is what it is. Agent. Let's see what I did wrong. All right, so has line of sight false, target, target position, and agent. We did that correctly, yes. Normalized thing with normalized target direction, yes. Set middle line of sight point to the middle line of sight and the normalized direction times the decision. Target object, get transform position, agent. No, this is all correct. Get closest edge. It's got to be in the agent. Get line of sight distance. No, I mean, it's got to be in the goal, agent to target distance, agent to object distance, get close edge, push back. We're going to do this, and the collision line of sight check, get middle line of sight endpoint to contact list and target up. So this determines if I have line of sight. But I think it's in the draw function because it's just not drawing properly. So that's inside of the, and this is knowing your code too, guys, right? So, so one of the reasons I can do it, even though Alex coded this first, is because what we do is we go through it, and even though it's not exactly my code, it's Alex's changes. I understand where it could possibly be. I know where to look. And so too, for you guys, you should start thinking about or understanding where you're going to look as well. All right, so let's take a look at the close combat enemy first in the CPP under the draw function. I bet you I left this the exact same way, and it did. Close combat enemy in the draw function. That should look slightly different, and I bet you that's where the issue is. Yep. Absolutely. So draw line goes from get position to the get current direction. I'm looking in the direction I want to, but actually where this should be is from the transform position to the, actually simpler, get middle line of sight point, endpoint. That's what it should be in here. And it's the same thing for the ranged combat enemy. So that should just make sure we change that here too, just for next time. So we don't need any of this. We can just type in get middle line of sight endpoint, which is what is in the draw function. So that's inside of the draw function. And now if I run things, it should actually run exactly as it should. So what we're doing is we're saying, hey, when we're in debug mode, you can see that we have line of sight, right? And if I move my ship around, so here's my target position, let's move my guy over there, it's pointing in the right direction because that's where line of sight would be, right? But we don't have line of sight right now, not from the target, not from the enemy. This is the close combat enemy. And as it moves closer and it hits a place where this line connects with me, you can see now I would have line of sight there if it wasn't for this obstacle. So it's going to have to go around here into a place where it has both a connection with the with this, and it's going to stop when I have line of sight. So that's when it has line of sight. So this is where it could start attacking, right? Or move to, in this case, because it's a close combat enemy, maybe the Klingon is going to ram. That's a close combat attack, and it's going to kind of run at the ship and smash into it. Okay. All right, so that works pretty good. Okay, well, how does the other enemy work? Does it work as well? Let's test that one too. So save all. Let's make sure we do that. And in the playscene.h, let's swap it out. So we'll swap out the close combat enemy for the for the ranged combat enemy. In the CPP, we have to do the same thing because that won't work anymore. So up here, we're going to have to swap this out for this one. So we're instantiate the right object. And then when we run it, we should see a different ship. It should be, oh, did we change it back to Reliant? I can't remember if we did. If we didn't, we're going to do that now. These are all little minor changes we're going to make. Yes, we did. Cool. So again, you can see that it's the same thing, same activities right now. The only difference is in the range action. So the Reliant is performing a ranged action, where before we were, making a range, a close combat action instead, right? So let me show you that. So there's the move to range action, which is what's happening here. And whereas if I swap it back, so let's swap it back to the way it was. So Control Z and Control Z. Wait. Control Z. Go. And now it's here. And we want to do this and show you this. Back to the Klingon again. And if we were to run this, you can see that on when it comes to the output, that we're going to see the decision tree that's going to be is now the patrol action until it gets to a point where it can see me. And now it's a move to player action instead of a move to range action. Okay. So that's how it works right there. So pretty good in terms of switching between, so we know the decision trees are different, and that's what we're going to work on next week in terms of for our next step. So let's take a look and see if we've done everything. So it looks like modify the action message. First kind enter the like it does in patrol and move to. Right. Okay, so we've done the action nodes. In order to see the changes in decision action, modify the action methods of all action nodes with an if check, which is what we did earlier. We just did it. He was talking about it here. We did it earlier. We're going to do a place scene modification. We have one less commit than he would have asked us to do. So let's go back and do that. So we'll bring in the GitHub desktop, and we'll add that in there now. Okay, so we're going to say tested both enemy agents in placing. Excellent. We tested it. It works. We know they're working now, and push to origin. So that's really all for me this week, guys. Any questions for the people that are here? Not a lot of attendance this week, which is troublesome. It's, but it is what it is. Any comments for the people? I know Tarif and Daniel, you guys are here. Any questions at all? Did you make yours work? Okay. You had a question and you forgot? Okay, Tarif. No problem. Thank you so much then. We'll see you guys next week. Thanks so much for everything. All right, take care. Thank you. I'll stop recording now. One more thing before, from an administrative perspective. So we did all this, and just for people who are watching online, remember that we're sitting here at week 12. Next week, we're talking about utility theory, some more stuff, tactical movement, and action execution. We're definitely going to think about obstacle avoidance next week, as well as configuring more actions for Lab 7. So lots of more things to do as we continue to power through and give you most of the things that you need to make sure that things are working. Okay, and that's it for this week. Thank you so much, and good luck. Hopefully this helped, and putting together your Lab 7. This is Lab 7 Part 2, and we'll see you guys all next week. Thank you.